Hello. Today I'd like to talk about vectors. So vectors are a very important part of physics. Today I will go over the definition of a vector magnitude, and vector components. For the definition of a vector is something that has a magnitude and a direction. And we typically write it out as some kind of an arrow. So a couple examples where you might see this. So we have a guy running up a hill and he's running at 10 meters per second. And he also has a bear behind him that's chasing him, running at 20 meters per second. Probably not going to go well. Another example is when someone might drop their phone into a toilet. The direction at which it's falling is down, and we could say at this moment it's falling down at 10 meters per second. One final example is you're trying to pull a box up a hill. You've got a string attached to the box, and here's our hill. You are pulling the box up with 10 newtons. So we have a magnitude of 10 newtons, and then our direction is up the hill. These are all vectors, and vectors will be used quite a bit, especially when we're dealing with velocities, like the phone or the man running, or forces, like the man pulling the box up the hill. So that's the definition of a vector. Now, the magnitude and the components, I'm going to go over these together. When we have a vector, let's say the man running up the hill, it's going up and to the right, it's kind of diagonal, and it's going in that direction at 10 meters per second. So every vector has a x component and a y component, x being the horizontal part and the y being the vertical. A mathematical way we can write out a vector is, let's say we have a vector called A. We'd write it out with a letter or name and then have the arrow symbol above it. And we set that equal to these kind of brackets with a comma in the middle. And we write out our x component and our y component. So for example, we could have an x component of 4 and a y component of 3. A vector like that would look something like this. Go up and to the right because it would have an x component of 4 and a y component of 3. So it goes a little more to the right than it does up. Up in our first examples, when we were saying the man is running at 10 meters per second or the man is pulling at 10 newtons, those are magnitudes, right? Because a vector is composed of a magnitude and a direction. When we write out a vector like this, it doesn't exactly tell us our magnitude, it's just telling us the components. Well, with these components, we can actually find magnitude. So the way we do that is we just use Pythagorean theorem. So looking at the components of a vector, they actually will make up a right triangle. And using the Pythagorean theorem, it's a pretty easy calculation. 4 squared plus 3 squared, and then taking the square root of that would give you 5. So it's just a basic 3, 4, 5 triangle. That would be the magnitude. And then to write out the magnitude, we can either use that same vector symbol and then put vertical lines on each side, and that would be the magnitude. Sometimes you'll also see it written out as just a very bold letter, and that would also signify the magnitude. Now that we know about vectors, a really useful thing we can do with them is something called vector addition. Vector addition, that's when we have two vectors involved in a system and we want to find out what are these two vectors going to be able to do together, or 3 or 4 vectors. We can have as many vectors as we want. For this example, we'll state it 2 just to kind of keep it simple. For example, you've got a brand new car and somehow it got stuck in the mud. This isn't good. Luckily, we had somebody in a truck stop by to offer help. They attached their truck in a chain to the car to try and pull it out. Fortunately, it wasn't enough to pull it out. The truck was slipping and we needed to call another truck to help us pull it out. We'll have a truck A and a truck B that will both pull on this car, trying to get this car out of the mud. Truck A is going to pull with 30 newtons, while truck B is going to pull with 20 newtons. They're each going at these diagonal angles, so they're not just pulling it straight out, they're pulling kind of an angle because they need room between them. Now our goal with these numbers is we want to find out what's going to be the resultant force that's going to pull this car out of the mud. And when it comes out of the mud, what direction is it going to go in? Well, just looking at how if truck A is pulling with a greater force than truck B, it's probably going to come up a little bit. But we want to know what's the exact angle it's going to come out at, and what is the exact amount of force that's going to cause it to go in that direction. Let's use vector addition and find this out. One of the ways we can do it is just using a protractor and a ruler. We can figure this out without really doing much math. Let's set 10 newtons is equal to 1 inch. We can use our protractor and figure out the angle of each of these. So we could draw out our first vector for truck A and say 3 inches at that angle. That's our 30 newtons. And then we can do the same with this second vector. Measure the angle and then measure out 2 inches. And then if we draw a resultant vector that goes from the tail of the first vector to the point of our last vector, that is going to be our resultant vector. So that resultant vector will tell us the direction the car is going to go when it goes out of the mud and how strong that force will be pulling it out of the mud. So that's how you could do it using just protractor, ruler, and graphing paper. I think a simpler way to do it is to do it mathematically. So to do this mathematically, the easiest way is we want to take each of these vectors and we want to find what are the components that make up each of these vectors. Looking at truck A first, it's coming up at 20 degrees. So let's find out then, what are the components, x and y components of this vector if that's 20 degrees? Go ahead and just using basic trigonometry, let's figure out what would be the components for that. If you round to 2 significant figures, you should get 28 for the x component and then 10 for the y component. And then if we look at truck B, let's also set that at 20 degrees from the horizontal, and he's pulling at 20 newtons. Doing the calculations for that triangle, the y component should be 6.8 and the x component should be 19. So great, now that we have those components, we can write out our vectors. So let's call the first vector just A. So we have an x component of 28, y component of 10, and then we'll draw out our next vector for car B. We'll label that just B. And we have x component of 19 and a y component of 6.8. Now everything's good except we missed one part, and that is when we are dealing with vectors and components, we have to be careful with our direction. And so because 6.8 is actually going down, we want to label that inner vector as negative 6.8. And we'll see why that's important in just a minute. So now we want to add these vectors together. And this is the easiest part because all we have to do are add the components together. So we'll call our resultant vector R. And so to find the resultant vector, we just add these components together. So first we do 28 plus 19, so that'd give us 47. And then we want to do 10 plus negative 6.8. So that's where the negatives are really important, because when you add these together, if we left that as a positive, it wouldn't give us the accurate resultant vector, but this time it does. So we have a resultant vector of 47, 3.2. So that looks really similar to what we had predicted, where we have it coming out at 47 to the right, then it goes up just 3.2. This is good. This means both trucks are mostly pulling it out to the right and just up a little bit. So hopefully that will be enough to get it out. So now we have our resultant vector. We want to know the magnitude and direction still. This just gives us our components. So the way we're going to find the magnitude is just how we did up here with our example vector. So we just use the Pythagorean theorem. We write that out, it would just be 47 squared plus 3.2 squared. And I'm taking the square root of that. So rounding to two significant figures, that should give us 47. And then if we want to find the angle, so if we can imagine this triangle down here, we want to find that angle right there. Just think of what would be your trigonometric function you want to use to find that angle. Well, an easy one you could do is, let's say, well, we know tangent. That would mean our inverse tangent of opposite over adjacent is going to be equal to our theta. So and that comes out to 3.9 degrees. Great, so that is vectors. So we went over the definition of a vector, components, and vector addition, and magnitude and finding the angle. So this is something that you'll use repeatedly throughout physics and also in any kind of engineering classes. And even if it doesn't make perfect sense now, as you practice it more, it'll become easier and make more sense. Good luck with everything, and that's it for this video.